Hello and welcome back, all you super IT nerds. If you made it through part 1 without killing yourself, you will now see how this all comes together. I'm very excited about this. So without further ado, this is Dr. Stiggy's part 2, actual complete examples. So we're going to move through this pretty quickly. Really quickly, in fact. I had to take off my headphones there for a second. So here's how to calculate the IP block we showed you in Anatomy of an IP. Subnet mask, easy, 29 divided by 8. 3, remainder 5, 3 255s, 5's 248. So here we have it, 255, 255, 255, 248. You got the increment, okay? Again, which one's different? This one. Above it, also, is going to be the active octet, okay? So it's going to be in the same, in other words, fourth octet over here is different. It's always going to be the fourth octet on the top because they may not line up exactly. So we've got our increment, we've got our nets, and we got the amount of host. So we're going to convert this to the IP block. The IP represents, again, effective octet in the top, which is important. This is right above 248. Of course, it's also just going to be in the exact same position as whatever it is on the bottom. So if it was in octet 2, it'd be in octet 2 here or here, whatever. So there are 32 nets. That's too many to graph out and figure out the range for 139, okay? It has an increment of 8. So the shortcut is just take 139 and divide it by the increment, which is 8. That's 17. And the integer, we don't care about the remainder, but we want to do 8 times 17, so we can see it's 136. So 139 is going to become 136. Again, 139 is our active octet. So 136 is the beginning of the range that will include 139. Here we go. Check that out, 173.10.221.136. That's our defining net segment for this block, okay? Now, it cannot be used, but we can add 1 and go ahead and do this right now. You can do it later for the first usable host address. So you add 1 to this, it becomes 137. Get these last two, I always like to do the next net segment so we get our real range here. Okay, so we're going to take our real range, which is 136, and we're going to add to that the actual increment. Okay, I want you to understand this. This is our active octet because of this. All right, this has now been changed to 136. Okay, 139 is going to fall in this range. So follow me. This is the net segment. Okay? Let's find the next one. So we can take 136 and we're going to add to it the increment. Okay? So what is the increment? It's 8. We take 136 and we add 8 to it and we get the next net segment, which ends in 144. So our range is from here to here. Of course, this is not used, but that is our defining net segment for the block. This is simply something we're using so we can back up to, and it just makes it so much easier. So we subtract 1 from 144, we get 143. That's our broadcast address. We subtract 1 from this, we get 142. That's our last address we can use. And again, you just add 1 to this, you get 137, first usable address. So, summary here, we got usable host 137 through 142. Host is 6, correct, verified above. All right, let's move on, try to go a little faster. But now we're down into like Class B, Class A, network, this is going to be a little more difficult, but watch how you do this, how easy this is. Pretty excited here, sorry about that. So we got 10 divided by 8 is 1, we got 1, 255, remainder 2, 2, 192. So there we got our subnet mask. We got our increment, 256 minus 192. Okay, again, this is the active octet. Up here is the active octet. Second one over here, second one over there. Nets is 256, 64 equals 4. We got host of 32 minus 10 equals 22. And of course, that's a lot. 2 to the 22nd power minus 2. You got 4,194,302. Again, just showing you the effective octets are 180, 192. Find the range. Okay. Again, quick way to do this. Take 180. We want to find what is the range. What does this fit into? So we take 180 and we divide it by 64 and we get 2. 2 times 64 is 128. So 180 is going to become 128. So down here it is, 10.128. The rest becomes zeros, always. 10.128, 0.0. That's the net segment, first part of this range. Let's go ahead and do the second part of the range. Again, what did we say the increment was? It's 64. Okay, again, that's the second one over is our active octet. Second one over here, it's changed though. But right here, we've got our first. We take that 128 and we add 64 to it. And the next net segment is 10.192, 0.0. Now we just back up, subtract 1 to get the above segment broadcast address. Now when you subtract 1 this time, you're subtracting 1 from the active octet, which is the second one over, second one over, second one over. So the second one over is 192 from the next segment. So we subtract it from 192. We got 10.191. And the last two zeros always become 255, 255. If you have 1 0, it becomes 255. But in this case, they both become that. Subtract 1 to get the last address, and that's 254. And then we add 1 for the first usable host address. Like I said, 10.128, 0.0, we add 1 to that, we get 1. So here we go. This just shows the next, like I just said, 128 plus 64 is 192. It gives you that, and you back up 2 to get your segment that you're really using. So our usable host is 10.128.0.1 through 10.191.255.254, and that gives us our host. So continuing on, here we go to example 3. Very quickly, just need to find the mask. Remainder 4, 2 to 5, 4 equal to 240, so you got it already. Effective octets, what are they? What's different here? Left to right, 240. Third one, up here, third one. So 92 and 240 are your effective octets. Find our increment really quickly, 16. Our nets are 16 also. The host is 32, and it equals 4,094. Find the IP block. Find the identifying net segment. Again, 92. That's our effective octet. We take that and we divide by the increment. We get an integer of 5. 5 times 16, which is what we divided by. We just want to see, what the difference, what the remainder makes here. 5 times 16 equals 80. So we know we're going to replace 92 with 80. And that's equals 172, 80.0. And it got zeros at the end. We just found our identifying net segment address. So let's find the next segment address. This makes our range. So we're going to take 80 again, 80 this time, Again, it's the active octet, third one over. We're going to add 16 to it. So we're going to get 172.21.96.0. That's the start of the next segment identifier, which we're only using so we can back up and subtract 2 to find what we're looking for. So here we go. That's our beginning segment. So right here, target segment. We got that. We got our next segment. We just added, our increment to it. 80 and 16, 96. Now to find our first usable host address, we just add 1 to this. 80.1. To find these two, like I said, I always like to go to the next segment, which we just identified. So our target segment is here. First range, it's going to be, our first range is, the range of this is between this and this. Okay, go to the last segment. We're going to subtract 1 from this. Again, subtract 1 from the active octet, which is the third one over. If you remember, starting way back up there. So we're going to subtract that from 96. We get 95. The 0 becomes 255. We subtract 1 from 255. We get 254. We're done. So if you notice, between these two segments, our 172.21.92.25 is located. As you can see, it's in between these two. There's a summary of it. Segment address. There you go. And broadcast not used. Let's go to the next one. So on this one, find the subnet mask, which is pretty easy. It's a 20. You divide that by 2, you get 16, you get 4 remainders, and you know what to do there. You got 2 255s, got 240, you got 0. Third one over, that's your affected octet. This third one over, affected octet and IP. So let's go ahead and get the rest of our stuff. 256 minus 240. We got an increment of 16. We're at 256 divided by 16 gives us how many nets we have. Let's get the beginning of the net segment identifier. 53 divided by 16, which is our increment. Gives us 3.3. I don't know why I put that there. Anyway, integer of 3. 3 times 16 is 48. So the beginning range, instead of being 53, is going to be 48. 175.25.48.0. Any number remaining on the right becomes 0. That's something that value 0. Okay, find the next segment identifier. Like I said, let's find the next using the increment, let's find the next segment. It's going to be 175.25.64.0. Can you see why this is? Okay. It's because we have 48. Okay, again. 1, 2, 3, 1, 2, 3. 53 became 48. Okay? And the next one, we're going to take 48 and we're going to add increment of 16 to it. So the next segment is 175.25.64.0. We know our number of hosts. So our first range, 175.25.48.0, our segment identifier identifies the beginning of our first range. And the next range, which we're not interested in, but we need to calculate for the broadcast address and last address, is 175.25.64, which is basically, it's 48 plus your increment of 16. So we got 175.25.64.0. Again, we're looking at the third octet as being our active octet. So we're going to subtract 1 from 64. We get the broadcast address here. 0 becomes 255. From this we subtract 1, we get 254. Again, this is a very simple one. You can do this, immediately. You just add 1 to this, the segment identifier, and we get our first address, last address, broadcast address. Okay, here we go with example 5. Another refreshing beverage moment here. So this I was telling you about the /14, where they get kind of weird, but it's very easy if you look at this. So let's look at /14. Just divide that by 8. We know we're going to have 1 255, and then we know what the remainder is. It's 6, so it's 252. And the rest are zeros. So we've already found our subnet address. And again, the effective octet this time is the second one over, which will be the second one here. So 3 and 252 are what you are concerned with. But from here on, mainly, it's 3. Of course, we're going to find everything else out from this first. So 256 minus 252 is 4. Increment. We got increment of 4. Nets of 64. And our hosts is going to be 18 zeros on the right. Have to put it in our formula, and we get that big thing there, 262,142. Now let's go ahead and find the next net segment. Okay? Let's find the net segment and the range that includes. Okay? So to find the first net segment, it's pretty easy in this case, but it's a little tricky if you kind of look at this. So what we're going to do is we're going to take the active octet, and this time we're dividing it by 4, but it's less than 1. So the beginning segment is 0. So we're going to change this. All right, it's going to become from 3, it's going to be 0. That's going to be our defining address, and they all become zeros over here. So 3 becomes 0, and the next 2 octets become 0. Net segment identified. That's it right there. This is going to represent our block we're doing right now. Let's find the next block beginning, so the end of our range. So we know what the increment is 4, and we know that this second one is what we're dealing with. So we're going to add 4. Leave the rest alone, 10.4.0.0. All right, let's go ahead and do our subtraction here. You take the 4, you minus 1, you get 10.3. The zeros become 255, 255, always. Now we're going to subtract 1 from 255, and we get 254. Okay, basically we're done. Okay? For the first usable host address, we add 1. I forgot to say that. That's always something you could do before anything. You got your segment here, just add 1 to it, 1. So we're done with that one. Let's go to example 6. Here we got a /21. We got a 2 and a 5 remainder. So we know 255, 255, and 248.0. What's different? 248. Third one. 10 is our active octet. So let's find our defining net segment. We do the increments of 8. Nets is 32. Host is 32 minus 2 is 11. 2 to the 11th power minus 2 is that. So we did all that. The first segment is 10 divided by 8, because that is our increment. 1 times 8 is 8, so 10 is replaced by 8. As you can see right there, that's our active octets. Becomes 0 on the right. So I'm speeding up here a little bit. Just go ahead and add 1 to that. Go ahead and you do that right now. You get the first available usable host. Now let's go ahead and get our next segment so we can back up 2. This is the easiest way I know to explain this. So now that we have our net segment for this address, and we know that it is the third octet over, we know it's 8. Now increment's 8. So we know the next one's going to be 173.26.16.0. Our range is going to be between here and here. So once we get to here, we have to subtract 1 from 16. Why again? Because it's the active octet. Third one over here. Subtract 1 from 16, it becomes 15. And the 0 becomes 255. We subtract 1 from 255, and we get 254. Again, we're done with this. We've got our first address, our last address, and our broadcast address. Example 7. Actually taken from the test. I guess they're trying to freak us out here, but it's a 26, so it's not that bad. So, I mean, it's like, again, 26 divided by 8 is 3. We got 3 255s, remainder of 2, 192. Effective octets. It's going to be the last one. It's going to be the fourth one over there, 161. We take our 192, we get our increment, 64. We got our nets of 4. We got our host of 6 to the 6 minus 2, 62 host. Okay? What we really are concerned with right now is the increment. It's 64. So we go down here. We're going to calculate the first subnet. So we're going to take 161, again, this, divided by 64, and actually equals 128. So we're going to take 161, it's going to become 128. This gives us our segment address. And we could go ahead and add 1 to that very quickly and get 129. It gives us our first address. Now let's go ahead and get our next segment so we can have the range here. So again, we come back up to our beginning network segment. We take 128 and we look at the increment, which is 64, and we get 192. So 155, 193.192, that's the next segment, okay? So now we can simply back up and get these last two. So again, it's 192 minus 1 is 191. And then 191 minus 1 is 190. So that's our broadcast and our last address. And that one's done. And I hope this explains it. If you look at the host range, 192.29 through 190, including 129 and 190 equals 62. It's correct. You can actually do the math yourself. See above, host equals 62. So this is our answer right there.